Well, hello everyone. This is Gary. In the last video, we went through the field of view um, in our roguelike tutorial. And as you can see here, we have our final result from that video. And we can get through our world here. And we can, walk through our dungeons. And uh, we don't see anything until, it ends up in our field of view. So, yeah. So scary, so dark and mythical. So with that, um, we're going to move off to the next part of this, which is actually implementing the first iteration of monsters. So yeah, so exciting. All right, so it says a roguelite with no monsters is quite unusual. So let's add some. The good news is that we've already done some of the work for this. We can render them and we can calculate what they can see. We'll build on the source from the previous chapter and get some harmless monsters into play. So, first off is rendering a monster in the center of each room. We can simply add a renderable component for each monster. We'll also add a view shed since we'll use it later in our main function in main.rs. Add the following. Okay, so I'm assuming that we're doing this, in our main function, yes. And we'll just loop through for room and map.rooms.iter. We're going to skip the first one because we don't want to render a monster in the room we're starting in. And we'll say let x and y room.center. And we'll say gs.ecs.create entity .width position xy. X and y marks the spot, I guess. With renderable glyph is RLTK 2CP 437, and this will be a G. FG RGB named RLTK red, and then BG is RGB named, and it should be black, right? And then we'll add another .width view shed, and they're going to have a view shed visible tiles vec new range 8 dirty true, and we'll do a build. And now at the bottom of this, we'll say we insert our map here at the bottom. I think everything should be good now. So if we hit run, we have our monsters. Make sure they look like they're in the center of each room. Yes, that's true. They're in the center of each room. That's good. So now it says notice the skip 1 to ignore the first room. We don't want the player starting with a mob on top of him or her or it. Running this cargo run produces something like this. Yeah, this is exactly what we have. That's a really good start. However, we're rendering monsters even if we can't see them. We probably only want to render the ones we can see. We can do this by modifying our render loop. Okay. So if we go look at our render loop, there's run systems, there's our tick. We have positions and renderables, and we can do the same for map. So let map, oh, we already Yeah, we do. So I'm actually just going to drop this down here just to make it a little bit cleaner. Put our fetches all in the same place. And then it's a position render, which is what we're doing here, positions renderables. And then we can say if map.visibleTiles idx, we can say ctx.set position x position y render.fg render.bg render.glyph. That's right. And now if we run, oh, map X not found in the scope. And renderables, draw map. Yes, fetch map. So IDX is not visible in the scope. Oh, it's because we're not actually, okay. So we need to say let okay, yeah, because we don't need the CTX that's set. We need to let IDX equal map dot XY IDX position dot X position dot Y. And now if we run this, sure enough, we only get this one corridor. We have a monster in the middle. That looks great. And if they go out of view, we no longer render said monster. That's great. Monsters don't do anything yet, so let's change that. It says we get the map from the ECS and use it to obtain an index and check the tile if it's visible. If it is, we render the renderable. There's no need for special case for the player since they can generally be expected to see themselves. The result is pretty good. Add some monster variety. It's rather dull to only have one monster type, so we amend our monster spawner to be able to create G goblins or O oryx. Here's the spawner code. Okay. So if we go back down to this room we're iterating, we can so we do a glyph, let glyph RLTK font car type, let roll equals RNG. We don't have RNG here, so we'll initialize it just before the for loop. That's fine. So we'll say let mute RNG equal RLTK random number generator. New, and we'll roll some dice here. So we'll say roll equals RNG dot roll dice 1, 2, and we'll say match roll. If it's a 1, we'll do a glyph equals RLTK dot 2 CP437 G. Otherwise, it's just an O, right? Underscore O. And then now, rather than rendering this, we can just render the glyph itself. Cool. So this needs to be expression can be glyph. Perfect. Obviously, when we start Adding in combat, we'll want more variety, but it's a good start. Run the program, cargo run. You'll see a roughly 50-50 split between orcs and goblins. Cool. So if we run this now, we should be able to see a G there. That's a G. That's an orc. Cool. And then if we, that's an orc. A goblin there. Orc. Yeah. So there's a lot more orcs than there are goblins, but it's just a random number generator though. That's the only problem with it. Okay, that's fine. Making the monsters think. Now to start making the monsters think, for now they won't actually do much beyond pondering their lonely existence. We should start by adding the tag components to indicate that an entity is a monster. In component.cs we add a simple struct. Okay. So we'll derive component. I don't like how it's doing that. Component and debug pub struct monster. Of course, we need to register in main.rs. Yes, we do. So we'll actually go and register a monster, player monster. And then now when we actually do a .with here, and this is, yeah, .with monster. Yep, that's what that should look like. We should also amend our spawning code to apply monsters. Yes. Now we make a system for monster thought. We'll make a new file, monster AI system.rs. Okay. So new Rust file, monster AI system. And we'll use specs. Actually, we need to go at the top here and we need to declare the module. Monster AI system, and we want to use the monster AI system, right? Now we can use specs prelude star, use super, view shed, position, map, monster, and we'll use RLTK, field view, point, and console. So we'll do a pub struct monster AI, and we'll IMPL, and this will be a system A for monster, monster AI. Cool. And type system data, and we're going to say read storage a viewshed, read storage a position, read storage a monster. Perfect. And then fn run mute self data self system data. Let viewshed position and monster equal data for viewshed position monster in reference viewshed reference position and reference monster dot join console.log monster considers own existence. Perfect. Notice that we're implementing console from RLTK and printing with console log. This is a helper provided by RLTK that detects if you're compiling to a regular program or WebAssembly. If you're using a regular program, it calls println and outputs to the console. If you're in WASM, it outputs to the browser console. Perfect. So we'll run this, see what happens. Things happening. Okay, that's fine. I don't actually expect anything to happen until we actually put it inside of this run systems. So, anywho, it says we'll also extend our system runner in main.rs. Yep, run systems, and we need to do the same thing. So we'll let mute mob equal monster AI mob.run now self.ecs. Now it should be actually running, and we should get a ton of console logs, I'm assuming. Yes. Okay. If you cargo run your project now, it will be very slow and your console will fill up. The monster considers their own existence. The AI is running, but is running every tick. Turn-based game. In a tick-based world, to prevent this, you make a turn-based game. We introduce a new concept in the game state. The game is either running or waiting for input, so we make an enum to handle this. So this is public enum run state. I believe this is going to be in so pub enum run state paused and running. And then this needs to derive partial equal copy clone. Notice the derive macro derivation is a way to ask Rust and crates to add code to your structure for you and to cut down on typing boilerplate. In this case, the enum needs a few extra features. Partial equals allows you to compare run state with other run state variables to determine if they are the same or different. Copy makes it a copy type can safely be copied in memory, meaning it has no pointers that will be messed up doing this. Clone quietly adds .clone function to it, allowing to make a memory copy in that way. Next, we need to add it to our state structure. Okay. Yep. And we'll say pub run state. In turn, we need to amend our state creator to include run state running. Okay, yep. And this is in here run state. Now we change our tick function to only run the simulation when the game isn't paused and otherwise ask for user input. Okay. So we should have run state running, run systems, run paused. So here. If run state self.run state equals run state dot running, we run the systems self.run state equals run state paused. Oops, I misspelled paused. Okay, And then as you can see, player input now returns a state. Here's the new code for it. Yep. So we have player input here, and we have the match none, and we can just return run state. Paused. And this should return run state. And then sum here. Perfect. If you launch now, so let's launch it. So we have our run state now, and every time we do an input, we should have a lot of console logs. If you launch cargo run now, the game is back up to speed, and the monsters only think about what to do when you move. That's basically a turn-based tick loop. Quiet monsters until they see you. You could let monsters think every time anything moves, and you probably will when you get into a deeper simulation. But for now, let's quiet them down a bit and have them react if they see the player. It's highly unlikely. It's highly likely that systems will often want to know where the player is. Highly likely, yeah. So let's add that as a resource in main.rs. Okay. One line puts it in. I don't recommend doing this for non-player entities. Here, there are so many resources available, but the player is when we use over and over again. Okay, so it's a player. We need to insert a new point, player XY. Okay. GSECS.insert point player Y. In player.rs, try move player, update the resource when the player moves. Okay. So try move player. We need to get the right resource, right player point. So let mute position equal ECS dot right resource, and this will be point point POINT. All right, and if we look at this a little bit more, we can see that. So let's see here. We have our point. We see people peoples.x. So peoples. Yep. And if we have this, we can say peoples.x equals POS. POS being. Oh, okay. Yeah. So peoples.x equals. Why is it doing that? POS.x. And then peoples.y equals POS.y. We can then use that in our Monster AI system. Here's a working version. Okay, so Monster AI system. System data, it's looking at the point. Viewshed and monster. Okay, and we actually probably just need to rewrite this. So let player position viewshed and monster equal data. That's fine. And we'll actually just go ahead and format this a little bit better. And this was for viewshed underscore monster and ampersand viewshed ampersand monster dot join. If viewshed dot visible tiles dot contains player position console dot log we need console log monster shouts insults. All right, now if we run this, read storage. The trait specs component is not implemented for point. All right. So read that's read expect. Read expect. Try that again. Now when we walk through, and the monster shouting insults every time we see him. Perfect. All right. We can, if you cargo run this, you'll be able to move around. Your console starts with getting monster shouts insults from time to time when a monster can see you. Differentiating our monsters. Monsters should have names so we know who's yelling at us. So we create a component name in components.rs. All right, yep, components.rs. If we go look, we can have derive. And this is component debug pub struct name pub name string. We also need to register at main.rs, of course. Let's go register it. And we also need to, let's see, which should be, you should be comfortable with by now. Also add some commands to add names to our monsters and to the player. So our monster spawner looks like this. Okay, so we have our glyph and then name. So let's go look at our if statements here. We have glyph happening here. And we'll actually, I don't like putting 2 lines of code on 1 line like what they're doing here. So we'll put a name here. So let name string name equal goblin, right? And then what is it complaining about here? Expected string, found string. That's weird, okay. That's a weird thing in Rust. And then orc, right? All right, and now we say with monster, with name format, okay. So we can say dot with name format, and it's some text, right? Ampersand name and I, right? I don't know what I is in this case, but it's something. All right, and now we just adjust the monster AI. So I don't think. Okay, now we adjust the monster AI system to include the monster's name. The new AI looks like this. So monster AI system. So it's console.log in its format, right? So we'll say ampersand format, and we'll say something here, and we'll say name.name, and we need to do a read storage here. Name. Let's create name. Okay, yeah, that's fine. And okay, and then we need to add name up here and name here. So we have viewshed monster name, player position, shed monster name, and that should be ampersand name here. So now if we run this, hopefully, with name, a local variable with a similar name exists x, and what is I up here? I is, index. So monster, so this is a main.rs. We have I and room, okay. I room, okay, map iter skip one dot enumerate. That should be good. So now if we're walking through here and yep, goblin number 9 shouts. Should see goblin number 7, yeah. Orc number 15. 11. Okay, cool. So we're good. We also need to give the player a name. We've explicitly included names in the AI's join, so we better be sure the player has one. Otherwise, the AI will ignore the player altogether. In main.rs, we include one on the player creation. So if we go back over to main.rs, we have the player creation right here. So we can do a dot with name, and this would be name player toString, right? And if you do a cargo run on the project now, so you can tell who's shouting, and that's a wrap. So if we run it now, we have monsters generating, everything is good, and our orc is shouting at me now, and orc number 5, so everything's shouting, it's all good. All right, thank you guys for watching, have a good rest of your day, bye bye.